Right, we're just going to stream on this. Can you let me know if the picture seems better than usual? Because I'm streaming in HD. We're going to stick this and I'll put everything on YouTube afterwards. But I think the chat's better on this anyway. Can you let me know if the picture seems better than usual? Because I'm streaming in HD. Right, hello, welcome to the next probability lesson. This is going to be a big one. There's going to be lots of different things in this. It's going to be a bit more practical than before. Lots of games and things like that. Probability is really the kind of important topic that you see a lot in the real world. So it's something which we really need to understand, not just be able to answer the questions on it. So to start with, as always, we'll have our warm-up questions. So have a go at those, please. Okay, so there you go, there's some warm-up questions to start with. Hopefully you've all found your way here now. Can you please let me know this on the chat if the picture seems better than usual? I think if Daniel's there, I think sometimes he says he struggles on the laptop. I'm hoping it should be about twice as clear now because I tried to film in higher definition. Otherwise, please have a go at those questions. I don't worry about YouTube. Sorry, YouTube is not. I've stopped streaming on there. I don't know what it was, and to be honest, if the picture is better now anyway, I'm going to look at the picture in this. If it's good enough, then I don't see a massive point in moving to YouTube because the chat is much better on this, and I can post pictures and things like this. So I will upload all the videos to YouTube afterwards. It's probably better to watch on that because you can browse for what you want. But I'm just going to stick on Facebook for now. If this picture is better when I look at it. Okay, so just another few minutes on these questions here, please, and I'll move into the probability stuff. We've got loads of cool stuff today. I will have another look at YouTube at some point. I need to test it properly to get it working, but definitely not for today, I'm afraid. Okay, let's go through this. It's a bit short for time now because of the message at the start. Right, so multiply these fractions. Multiplying fractions is really easy. All you need to do is multiply the tops and multiply the bottoms. We'll be using this today as well. So 2 times 5 is 10, 3 times 6 is 18, and then always look to see if you can cancel it down. And this one, they both divide by 2, so you end up with 5 over 9, 5/9. Okay, question 2. You can cancel at the beginning if you want, that's great. Not necessarily, but it can help you. Right, question 2, 2 significant figures. So 1, 2, 3, 4, 5 significant figures there. We're going to round to there. So you're rounding after the 7. So it's going to be 67,000. Question 3, tricky one this one. Okay, very difficult. 1 metre squared to centimetre squared. Now, you should all know there's 100 centimetres in a metre, but in a square metre it's different. So this is your metre square here. Okay, this is 1 metre by 1 metre. It's obviously 1 square metre. Let's look at this in centimetres though. In centimetres, we've got 100 centimetres and 100 centimetres. If you times those together to find the area, you've actually got 10,000 centimetres squared. So 1 square metre equals 10,000 centimetres squared. Another way to do that, if you times it by 100 normally, because it's square metres, you times it by 100 squared, or times it by 100 twice. 100, and then you go to 10,000. So one that catches a lot of people out there on both the foundation and the higher paper. Question 4, 3.2 times 8. If you're times in decimals, first times without the decimal bit in. So we're going to do 32 times 8 first. Okay, when you do 32 times 8, you're going to end up with 256. And then because we're doing 3.2 times 8, we need to divide it by 10, so it's 25.6. And finally, question 5, the first one, substitute 7 into that formula. So we've got 4 times 7 is 28, then plus your 8 on is 36. And B, we are working backwards. This time, if t equals 56, we need to get to y, so we're going to take away 8, then we're going to divide by 4. So you would minus 8, and then divide by 4. So if you take away 8 from the 56, you end up with 48, divided by 4 gives you 12. Okay? So you end up with 48 divided by 4 equals 12. Okay, happy with that? Right, okay, so moving on to our main topic, which is probability. We're not going to cover everything that's going to be on the that you need for your GCSEs in this one. We're going to cover quite a bit of it, looking at understanding the probability scale, use fractions to show the different probabilities, really important that one. Sample space diagram we'll look at, and also calculating the probabilities of multiple events. We are doing this quite early. This is tough, but it's the most useful thing about probability, because we often want to find the probability of lots of different things all happening. Okay, so start with, this is our probability scale here. So you get questions like this. It's a good way to think about the chance of things happening. Probability is about the chance of different things happening. You could talk about the chance of your football team winning a match. You could talk about the chance of getting a certain number in a dice. You could talk about the chance of you passing your GCSEs. There's a chance. You don't know exactly what's going to happen in the future, but you can make good predictions based on what you're doing. If you are well prepared for your GCSEs, the chance of you passing, of you getting the grade you want, is going to be much higher. And we can do this on the scale here. So we've got impossible, which is absolutely no chance. Impossible means it absolutely cannot happen. Okay, not it's very unlikely, it cannot happen. Certain means it definitely will happen. And then you've got everything in between. Even chance in the middle is when you've got just as much chance of it happening or not happening. Okay, so we're going to start by trying to place some events on here. As well, numbers. Certain is 1, a whole 1. Impossible is 0, and then you've got everything in between. Even being a half, or you could say 50%, or even 0.5 as a decimal. So anything in between has got to be less than 1. So you kind of the probability of 2. If you get an exam question that says, what's the probability of this happening, and you write down 3, something's gone wrong. It's got to be less than 1 because you can't get more than certain. So what I've got is, so looking here, so we can use fractions. Where's our, oops, where are my events? So we're going to put some events on this, okay? So can you copy this scale at home for me? Can you copy the scale down? Okay, so you've got the scale drawn down. Okay, I now want you to place these events on. So event A, okay, is getting heads on a fair coin. So if you flip a coin, and it lands on heads, what's the probability of that? Where would that go on the scale? Okay, so getting heads on a fair coin, where would that go on the scale? So place A on where you think it needs to go. Okay? B is Christmas being on the 25th of December this year. So where would B go? Christmas being on the 25th of December. So think about where B would go on your probability scale. So you can place B on your scale at home. Okay, C would be winning the lottery if you had 1 ticket. Winning the lottery if you had 1 ticket would be C there. So where would that go? Again, place it on your scale where you think it would be. Okay, and the last one is D. Rolling a dice and getting a 5 or 6. Rolling a dice and getting a 5 or 6. Where would that be on your probability scale? So you've got 4 events to place on your bar there. Place them as accurately as you can, please. So think about where exactly they would go. Okay, right, we'll have a look at these. So getting a heads on a fair coin is an even chance. It's fair, so it's got to either land on heads or tails. So it's a half. It's got a half chance of heads, a half chance of tails. So A would definitely go right there. B, Christmas being on the 25th of December, that is a certain event. That's always when it is, that's not going to change. So B will be there for certain. Winning the lottery if you have 1 ticket, extremely unlikely. Practically impossible, but not absolutely impossible. So it's going to be, you'll be expected to put it anywhere as close to 0 as possible. So if you put C close to 0, you are going to get the mark for that one. And D's the hardest one, getting a 5 or 6. Okay? Compare it to here. There are 6 numbers on a dice. 5 or 6 is only 2 of them. So your chance of doing this is less than 50%, less than a half. It's actually going to be 2 out of 6 or a third, so you want to be placing it about there. Okay, and we'll look at why it goes there once we do some more fraction work with this. So that's roughly where your different bits should be on the scale there. You get these questions in GCSE, they are very common for coming up. There is a lot of probability work on the papers. On every paper, so there's 3 papers, there's a probability question on every single one of those papers. So it's a topic which needs work. So we always use fractions. So we talked about this. You can calculate probability based on the information you have. Use fractions, decimals or percentages. So what is the probability of flipping a fair coin and it landing on heads? Fair means it is not a weighted coin. Fair is a really important thing in probability to use, a really important word. It means it's what you would expect to happen. It doesn't always mean it's an equal chance. It means it's what you would expect to happen on that coin. There's nothing wrong with it. So if landing on heads would be 1/2 or 0.5 or 50%. But stick with fractions. The only reason to go to decimals or percentages is if it changes it for you, if the question asks you to do it something else. Stick with fractions, it's easier. So working out some probabilities, you quite simply do the number of successful outcomes over the total possible outcomes. So what is the probability of rolling a 6 on a fair 6-faced dice? What is the probability of rolling a 6 on a fair 6-faced dice? So there is 1 6. There is only one successful outcome. One way of winning this game. If you think everything's a game of probability, it helps. And there are in total 6 different outcomes. So the probability will be 1 out of 6. As a fraction, it must be written like that. You can't write 1 out of 6 in words. You've got to write it as a fraction. Okay, so we're going to have a go at some of these questions now. So you've got 7 questions, I think, to have a go at. So the way this works is you've got 10 random cards there, 10 random cards, and you pick one of them at random. Another important word to use. Random means I'm not looking while I'm picking it out, I'm picking a random one, they're all shuffled together, picking one of those cards, and I want to know what is the probability of choosing an 8. Write down your fraction. What's the probability of choosing a number bigger than 3? Write down your fraction. Okay, so try and answer those as fractions, please, with probability. And then we're going to look at something which you might think is amazing to do with the chance of things happening. Okay, you all seem very clued up on this, which is great. Okay, it's definitely going to get more difficult after this. But well done all those people that got those questions right. Fantastic. Getting them in the right place as well. Brilliant work. Okay, so let's have a go at these. A few tricky ones on this, but this is the kind of stuff that whatever grade you want to be getting in your GCSE, you should be getting these questions right every time. Every single time. Okay? That does say yellow number. You're right. There are no yellow numbers there. You might say it's a trick number, but a trick question. Sorry, but they're just trying to check you know your stuff. That is probably you might get that coming up, but it's not a misspell or anything like that. It is saying what's the chance of getting a yellow number. Okay, right. How are we doing? Okay, brilliant. Right, let's have a look at those. So those are your answers. 1 out of 10, 7 out of 10. You are not allowed 3. It says bigger than 3. An even number, okay, that's half of them. A red number, 3 out of 10. A number that is not red, so there's 3 that are red, there's 7 that aren't red. A prime number, your prime numbers are 2, 3, 5, and 7. So 4 out of 10. And a yellow number is 0. If you mean 0, let's just write 0 down. Let's not write 0 out of 10. It's just 0. Okay? So try and write that. It's just a bit neater. Now then, some of you are probably thinking, well, I cancel this one down. I cancel this one down. Okay? That's great. Okay? You're never going to lose a mark for that. But probability is actually better not to cancel it down a lot of the time because it's easier to compare. So I can see, if I've not cancelled this down, I can see that this one is slightly more likely than this one. So I would say don't bother cancelling down your fractions in probability because it might help you on the bigger questions. If you do cancel them down, you are never going to lose a mark. Even if you mess up while you're doing it, you'll still get the full marks. So it's not a problem, but it helps to have them all out of 10 because you can compare them really easily. So just think about that. Okay, right, so I want to think about what is the chance of getting 10 heads in a row. So getting 10 heads in a row is going to be pretty tricky. Getting 1 head we know is a half. What's the chance of getting 2 heads in a row? So you're going to flip a coin and get 10 heads in a row. Is it possible? How likely do you think it is? Okay, has anyone got any ideas? How likely do you think it is to get 10 heads in a row? Any ideas for 10 heads in a row? So you flip a coin, head, flip another coin, heads, flip another coin, heads, and so on and so on and so on. Is it even possible? Near impossible, okay? 10 out of 100, okay? Not very. Right, well let's have a look, because this person here, okay, this is from a Channel 4 programme, and he got 10 heads in a row apparently. Well, he tried to do it anyway.
So with future events. And I'm going to show you something now which is impossible in exactly the same way. And that is to toss a coin fairly 10 times in a row and have it come up heads every time. Now we film this under controlled conditions with multiple cameras that won't cut away, and it's a genuine coin with heads on one side and tails on the other. But I want you to watch this and try and work out how it can be possible, because the key to understanding this is the key to understanding the system. 10 heads in a row. Watch.
See if you can check if he's cheating.
One. That's heads. 2. That's heads. 3. Heads. Heads. That is 4. Heads. 5. 6. One more to go, and I'll stop. 7. 3 more. 8. 9 heads, last one. 10 heads in a row. Thank you very much indeed.
Okay, so he just got 10 heads in a row on a fair coin. How on earth did he do that? How did he get 10 heads in a row? Is it even that unlikely? So I'm going to show you how he did it at the end of the lesson. We're going to look at it itself, try and work out the probability of that. So multiple events. So we're looking at the chance of more than one thing happening in a row. With the coin, it was 10 coin tosses in a row. We're looking at different events here. So what we're looking at here, what's the chance of getting a head on a coin and also getting a 5 or higher on a fair dice? So we need to flip the coin and roll the dice. You need to get a head and also a 5 or a 6 to win the game, if you like. Always think of things as games as probability. So how do you calculate that? And it's all to do with multiplying probabilities. Because the chance of getting a head on a coin is a half. The chance of getting a 5 or a 6 is 2 out of 6. So we want to do half of 2 out of 6. Half of 2, 6. Or times, because of means times. So to work this out, we would do the coin is a half. The dice, okay, 5 or 6 is 2 out of 6. We would multiply those together to give us, and we just did this in the starter, 1 times 2 is 2, 2 times 6 is 12. So you've got a 2 out of 12 chance of that happening, 2/12. Okay, so multiplying them together. This is really, really important because it's not often in real life that we want to work at the chance of just one little thing happening. There's all sorts of stuff that go together. When they're working out the weather forecast, making predictions, they're multiplying loads of different chances together to give you the chance of it raining. So we multiply everything together. So I want to have a go at some of these questions. These are high-level questions now. Okay, we're looking at grade 5 and 6 for these questions. So we're even pushing to 7s. These are high-grade GCSE questions. Okay, so we've got in this situation here, a square spinner is spun and a triangular one is spun. So we spin this one first and then the triangular one. I want to know what's the probability of getting a 2 and then a 3. So work out your probabilities and multiply them together. Okay, hopefully that makes sense. Can we have a go at these questions then, please? Question 5 is really, really tough. Be very interested when you can get question 5 right. Very, very difficult probability question. It's all hard, but question 5 is really tough. Okay, right, good luck.
Can you help me draw my ball?
Okay, but if you need any help. So we set out your first probability, your second probability, and then multiply them together. So we'll just look at the first one to see if you're doing the right thing. So we've got a 2 then a 3. So the chance of getting a 2 on the square spinner is 1 out of 4 because there's 1 2 out of 4 chances, 4 different outcomes. The chance of getting a 3 on the triangular spinner is 1 out of 3. And then you multiply those together to give you 1 out of 12. So that is question 1. Okay, you're just multiplying those probabilities together. Okay, let's have a look at these and then we'll look at the last one properly. So your answers for the second one. So the second one, question 2, is going to be a 1 and then a 2. So the chance of getting a 1 on the spinner is 2 out of 4 times by 1 out of 3. So that one is 2 out of 12. Question 3, an even and an odd. Well, there's only one even number on the first spinner, so that's 1 out of 4. And then in the second one, there are 2 odds, so 2 out of 3, which gives you 2 out of 12. Question 4, a 2 and then not getting a 3, so we got 1 out of 4 times by not getting a 3 is 2 out of 3, which gives us 2 out of 12 again. And the last one is tough, because there are multiple ways to get the same number. Okay, you could get 2 1s, so we could get the 1s, which would be 1 out of 4 times by 1 out of 3. We could get 2 2s, so that would be, so that's 2 out of 4 there. That would be 1 out of 4 times 1 out of 3, and then we could also get the 3s, 3 3s, 2 3s, which would be 1 out of 4 times by 1 out of 3. So you've got 3 separate ways of it happening. So you need to work out each one. So this one would be 2 out of 12. This one would be 1 out of 12 and 1 out of 12. And then you can have all of those. Another reason why it's really good not to cancel them down. So in total, we've got 4 out of 12 of getting 2 the same. So the last one is tough. So it's a tough question. That would only be on the higher paper. Okay? Right, before we look at that coin, let's have a look at what is the probability of getting 10 heads in a row. So think about what we've just done. Okay? Can anyone work out the probability of getting a head, then another head, then another head, then another head, then another head? Can you work it out by doing what we've just done, but with your 10 coins? It's the same chance on each coin, but you need it to happen those 10 times in a row. So think about what you would need to do with those probabilities. Okay, so the coins. Let's have a look. So it's going to be a half, because that's the chance of the first coin, times by a half, times by a half, times by a half, times by a half, and we're going to do this 10 times, aren't we? I can write it down 10 times. So it's going to be all those. That's your probability. Now the top's easy. 1 times 1 times 1 times 1 times 1 is 1. Then we've got 2 times 2 times 2, so 2, 4, 8, 16, 32, 64, 128, 256, 512, 2025. 1024. So that is a chance of getting 10 heads in a row. 1 out of 1024. So how did he do it? How did Darren Brown manage to get 10 heads in a row? Okay, we've got the rest of the video at the end of the lesson explaining how exactly he did that. How did he get 10 heads in a row when the chance is 1 out of 1024? Okay, we are going to play a game now. Okay, so this game is a horse race. Okay, the kind of thing you get at a fairground, and it's fair, it's random. So what I want you to do is on the chat, you pick a horse from 1 to 6. And the way the game works, I roll a fair 6-face dice, and if your horse number comes up, you move 1 space forward. Okay, and whichever horse crosses the finish line first wins. So you can obviously pick 1 to 6 horses, there's no point, that's all the dice goes up to. So if I roll a 3, horse 3 goes forward 1 space. If I roll a 2, horse 2 goes forward 1 space, and so on. So pick your horse number, put your horse number in the chat, and we will see who wins. Okay, so we got a 1, 3, 4 and a 4. Another a 5. Another 4. 4 is very popular for 4. Another 4 as well, goodness me. 5 there as well. Okay, no one going for the horse number 6 or horse number 2. Right, well, let's have a go. So we'll have a look at the race. Keep posting your numbers on there. Okay, so here we go for the big horse race. There's a finish line. And horse 6 forward, horse 6, then we've got horse 6, no horse, oh, we got horse 6, Tanya Rook's got horse 6. And horse 2 catching up, and horse 4 comes out. Horse 4 very popular today. Horse 1. Horse 1, 4 takes the lead. 4, 5 and 3 haven't started, another one for 4. Horse 6 goes. Horse 6 catching up, there goes 5, 3, still not out of the stalls. Horse 6 in the lead. Horse 5 up, horse 2 again. They're very close. Poor horse 3 has not moved yet. Horse 4, the very popular choice, out in the lead there. Horse 3 finally gets going after having some breakfast. Horse 4 is there. Horse 4 again. Horse 4 popularly backed. Horse 3 coming up now with a late start. Can anyone catch horse 4 up? Horse 5, horse 1, horse 3, horse 4 again. Nearly there at the end. We are still going. Horse 3, after a late start, is suddenly catching up. Could this be an amazing comeback story? Horse 1 now. Horse 4 is moving. 1 more to go for horse 4. Can anyone catch horse 4? Horse 1 is up there now. Horse 6, horse 5. Horse 3 seems to slow down. 6 again on the outside. Horse 5, horse 6. It's neck and neck at the final. And horse 3 comes there again. Horse 1 wins the race. Horse 1. So, horse 1 wins the race there. Okay, looks fair. It was random. So, what happens next is the fairground guy. Okay, congratulations to horse 1. Did anyone go for horse 1? Gracie May Griffin went for horse 1. Congratulations. Oh, she just changed to 4. Oh, did no one go for horse number 1? She changed. Unbelievable. So no one even went. Who did? Oh, well done, Daniel. We only went for horse 1. Okay, right. So, game changes this time, okay, because this time, same kind of rules, but he wants to improve his business to have more horses so more people can watch. So he now has 12 horses and rolls 2 dice. So 12 horses, 2 dice. You roll the 2 dice, you add up the total, and whatever the total is, if it's your horse, you move forward 1 space. So you add the dice together, the total comes up, because the most you can get is 12 and 2 dice. Your horse moves forward. Okay? So, pick again, pick your rule, pick your horse you want, please. So we can have 1 to 12 this time. Will anyone pick the winner? 1 to 12. Horse 1 to 12. They are fair dice. So who knows what are the best horses to pick? Does it matter? Is it random? Who knows? But we're going to look at this. We're going to do loads of trials, so we should get a nice fair result. So we've got 8 and 9. You can only pick 1 horse, please, just 1 horse. So we've got 8, a 9, another 9, a 6, a 7, No one go for horse number 1 this time. Horse number 1 won last time. He's ready, he's confident. The 12 there, brilliant. Okay, horse number 1 from Daniel. Okay, nice, horse number 1. Okay, so we're going to run this through a bit faster than before. This time, to make it fairer, okay, we've got loads of spaces. Okay, we've got loads of tiny spaces. So it's going to be, it looks to me like about 200 dice rolls to win. The more you do, the more results you do for an experiment, the better it is in all experiments and in probability. So you're going to go really fast, and you see this like a proper race here. So here we go. And they're off. And it looks like, oh, 1 hasn't even moved yet. Horse 6, 7, 8. Oh, we're going to run time over. Oh dear. Oh, no, what that means. Oh, we'll try again. No, you won't. Right. Well, we're going to have to call it there, aren't we? It looks to me like horse number 8 won that race. So, horse number 8 won that race there. But look at this. Does this look like a fix? You're right, 1 cannot be picked. So, that was a bit silly to pick horse number 1 because you can't get a total of 1 with 2 dice. This looks more fixed to me. It doesn't look random. Okay? And it always goes in this kind of arrowhead pattern. So why is that? Why do these horses, why do horse 6, 7 and 8 have more chance of winning? Horse 6, 7 and 8 have more chance of winning than the others. In fact, 7 actually has the most chance of winning this race. Why is that? Why does 7 have such a good chance of winning this race when it is with fair dice? In fact, I'm surprised 8 won. 7 nearly always wins. I bet if we got to the end, 7 would have won that race. So why is that? Okay, and it's to do with the different ways of making your combinations. So if we think about this, how many ways are there to make a 12 on 2 dice? Tell me the ways to make a 12 on 2 dice. List it in the chat. How many ways are there to make a 12 on 2 dice? How can you make a 12? There is one way, isn't there? There's one way to make a 12, 6 and 6. What about a 7? Think about the different ways there are that you can get a total of 7 with 2 dice. I'm telling you 7 has the biggest chance of winning. How many different ways of making a 7 are there? Think about your 2 dice. So you've got dice 1 and you've got dice 2. Okay, so think about your 2 different ways of making a 7. All the different ways with your 2 dice. Okay, we've got 5 and 2 there I've seen. We've got 4 and 3. Any others? 6 and 1. Any other ways there? Okay, so we've got 3 there, but what if you got a 2 on this dice and a 5 on this dice? Or a 3 and a 4, or a 1 and a 6? 6 different combinations. So 7 is much better than 12 in this game. Much, much better. Okay, and we can use, to get all the combination, we can use what is called a sample space. So a sample space here is a brilliant way to get all of your different combinations. So you can put your dice 1 there, your dice 2, and you can add them all together. Okay, I'm not going to ask you to do this one because I'm sure we can work it out here. So you add them all together like that, and that gives you all the different combinations. So you've got every single possible one. Okay, so have a look at these questions now. Last questions we're going to do. Can you work out, so what is the probability in this game of rolling a total of 4? So think about how many 4s there are. Remember, your answer is going to be a fraction because they're probability. So see if you can answer these 5 questions using this sample space based on this horse racing game, and then we'll finish by looking at how Mr. Darren Brown managed to get 10 heads in a row. And yes, opposite ways definitely count because it's another way round of getting it. So opposite ways do count because if you roll the dice, this dice, you can get a 5 on that one or a 1 on that one, and you can still end up with a 7. And this shows that the opposite ways count as well because you've got a 3 and a 1 and you've got a 1 and a 3. So opposite ways do definitely count in most probability things, unless it says in a particular order. Okay, so fractions for these answers here. Think about what it's going to be out of. Okay, it's definitely not going to be out of 6 or it's not going to be out of 12. It's out of the total number of different outcomes, of different possibilities. Okay, let's have a look at your answers. So you should have 3 out of 36, 1 out of 36, so 36 in total. 6 out of 36, 10 out of 36, and 3 out of 36. One like this we could have worked out anyway, because we could have said, what's your chance of getting a 12? Well, you need a 6 on the first dice, so that's 1 out of 6, and you need a 6 on the second dice, which is 1 out of 6, which gives you 1 out of 30. I got one today. 1 out of 36. So it's the same thing as what we've done before. It's another way of looking at it. So I'm sure you are all interested in how he managed to get 10 heads in a row. So let's have a look. So this is how we do it.
10 heads in a row. Watch. To predict a run of 10 heads in a row and then make it happen is hugely unlikely. The chance of it happening is about 1 in 1,000. However, if you flip a coin thousands of times and record the results, somewhere along that line of heads and tails, a line of 10 heads is actually very likely to appear. Okay, 10 heads in a row. That's 1. To work out the system, you need to understand that we can only know what comes from our own limited experience. And our experience can often be very far from the truth. I can't see the ball anymore. Here we go. 10. What you saw was the final minute of what was an excruciatingly long day. We filmed for over 9 hours until eventually a clear run of heads appeared. 9 heads. Last one. The impossible became inevitable. 10. 10 heads in a row. Thank you very much indeed. You now have all the clues neat.
Okay, so you can see there, he got 10 heads in a row because he kept going and going and going and going and going over and over again until eventually it came in. He probably tried it somewhere in the region of 1,000 times. Because it says 1 out of 1,024 times you will get 10 heads in a row. So we was filming for 9 hours to get that. Okay, right. So it's the end of the lesson. You got some exam questions which I'll attach to this. They've been posted on the site as well. Please have a go at those. Apologies for the YouTube issues, but hopefully this is a better quality video anyway. So if you can have a go at those, if you want to post me your answers, I'll post your answers up and check your work for you. But well done. I hope you've learned a lot about what for me is a very interesting maths topic of probability. Okay, I will see you next time.